Alright, today's service call is on a Delfield little one-door reach-in with the cold rail on the top. It's a refrigerated cold rail. The complaint was that the bottom was not working, but the top was. Okay, so just doing a quick check. I had to move it outside so I could work on it easier. Evaporator fan motor's running. First thing I'm going to do is verify warranty status, so I'm going to call the manufacturer. This particular manufacturer gives a 3-year parts and labor warranty. So the first 2 digits designates the year, so this one very likely might still be covered under warranty. We're going to call them depending on the ship date. So we'll call and verify that. So anytime you're doing warranty work, you always want to call and get approvals before you start messing with things. Okay, so we're going to start by taking the back of this unit off. We'll do a visual inspection. Dive into the control system and figure out what's going on here. Get to work on enough of these, you kind of get a routine going. I verified that there's no warranty left by calling the manufacturer. At least there's no labor warranty. They're still covered under a 5-year compressor warranty. So I'm pretty comfortable with how this box works. So power comes in, goes into the temperature controller for the rail, and then goes to the temperature controller for the bottom evaporator. Bottom evaporator fan motors run 24/7. It's controlled by a thermostat that controls a solenoid valve. This rail temperature controller right here controls this solenoid valve, which is for the cold rail. The compressor turns on and off via the low pressure control when the system solenoid valves open or close. So there's a solenoid valve for the bottom section in the evaporator, and then there's a solenoid valve for the rail. Plug this guy back in and see what we can find. Very common place for leaks on these is on the suction stub tube of the compressor. Before I go any further, I'm just going to visually inspect it. Yeah, I'm thinking this compressor's been replaced. So what happens is the insulation runs down into the suction stub tube, and it creates like almost a P-trap, and the water rusts out the tube. This one's been replaced before. It looks like the insulation's been pulled back because that's a fairly new compressor. It doesn't look like there's a leak there. Alright, so the next thing we're going to do is open up the evaporator. So we've got our temperature controller right there, and that controls the solenoid valve on the inside. So I turned it off and I turned it on, and I don't hear the solenoid valve clicking. So that's not a good sign. Go ahead and pull that coil apart and test that guy. So that thermostat should be telling that solenoid valve to pull in, and I don't think it is, so we need to test it to see if it's bad. So what we're going to do is test from one lead to ground. Okay, so here's the problem that I have. I noticed that when I plugged this unit in, I didn't have a ground. That's probably why I'm not getting a good ground. It's probably got a really shitty ground right now. Here we go. I tested to a fence post that's next to us, and we have 120 volts. So, and this is demonstrating what a bad ground would do. And I'll show you guys the plug here in just a second. But if I touch, I ground myself out and ground myself to something else, I'll become the path to ground, and you'll feel a nice little tingle. So we've got 115 volts coming into the control, and obviously we're not going to have anything going out because the control's not connected. So what I'm going to do is put my meter on continuity. We're going to change it to audible tone. We're going to test across the temperature controller. We have no tone, and let me make sure it's on. That temperature controller is turned all the way on, and we have no tone. There we have tone, but here we don't. So we have a bad temperature controller. Now, whether or not that's the only thing that's bad, I have no idea. That's what I'm talking about. That's why I was only getting like 50 volts or something, because it wasn't a good ground. The unit wasn't grounded properly. So this is our temperature controller right here. Go ahead and get that guy pulled off. We'll get this guy pulled out right now. I got some better gloves on so that my hands don't smell like salad bar for the next week. Call the term prep table funk. It stinks to high hell. That coil is pretty corroded, and if it's not leaking right now, it's going to be leaking soon. So it needs to go on there like that. That needs to go on there like that. You want to make sure you get the numbers right so that way they make sense and they're not all ass backwards. And then try to install the sensing bulb. That way it's not twisted up and gonna rub out on something else. I work on a lot of Delfield units, so I stock a lot of their parts. And we always go back with OEM parts. I should say I try to go back with OEMs as much as possible. This particular unit uses a constant cut-in temperature controller, so it's very important that we put one back in because that's the defrost. You can actually hear it actuating now, unlike before. So you can get your sensing bulb pushed all the way back up into there. Alright. Be honest with you, normally I would have leak checked that coil too, since I had it apart, but I'm being lazy and don't want to walk back out to my van yet, so we'll throw some service gauges on this guy when we're down and check it. Evaporator fan motor's running. There you go. Set it to number 3. So we're just watching the unit cycle right now. It's going to take a little while. It's going to be ons and off, so it's currently pumping down right now. Because of the constant cut-in temperature controller, it's going to cycle a few times because the evaporator coil's got to kind of stabilize out. The TXV's, you know, flooding when it opens, and then it's just kind of going back and forth, so we're going to see these cycles happen. Alright, so the unit's operating, and here's where we're at. We're running an 85-degree ambient. Our refrigerant pressures are good. Once I changed the temperature controller, we started, I had the box at 47 degrees. Well, actually, no, I had it at 51, and then it turned off at 47, and it cycled multiple times. 47, 42, 44, 39, 42, 36, 41, 35, 40, 34. That was our final, where I have it set at number 3 on the temperature controller. It's cutting out at 34 degrees in the box, turning on at 40. This is all that really matters. This is going to be our product temperature, the cut-in temperature, okay? That's the constant cut-in control doing its job. Now next, at 34 to 40 degree box temp, here was my pressures. 48 psi low, 252 high, for a saturation temperature of 14 degrees. So we're running a 14 degree coil with an evap TD of 26 degrees and a 105 degree condenser with a condensing TD of 20 degrees. Okay. This is an interesting number I came up with while I was waiting for this unit to cycle. This unit cycles off for 1 minute and 45 seconds and it runs for 32 seconds. So I average this up to a 2-minute off cycle, rounding that up to 2 minutes. That means this unit cycles 720 times per day. And you wonder why we go through starting components on this. And this is with me leaving the door shut. So that number will go up once the kitchen staff starts using this box and opening and closing the doors. It's an interesting number, how to think how many cycles per day. It just shows you why we lose compressors on these things so often and why we go through starting components. These things run hard. You got to give props to these little compressors that do their job because they bust their ass. Alright, so we're operating properly. One thing I do want to bring up is that Delfield themselves has informed me that when you are troubleshooting this unit, so long as you're not having a problem with the top section, the cold rail, you want to shut the top off when you're analyzing your refrigerant pressures, okay? Because the top is a static cold rail, meaning that there's no evaporative fan motor. It's just a pan, okay? It throws the pressure readings off, and they prefer that you check pressures with the top section shut off. Alright, so we're looking good. Now, if you're having problems with the top, then you can turn it on and diagnose by superheat on the TXV. But they won't tell you pressures what the top should be running, because it's kind of difficult for them to get those exact pressures because they don't know the exact temperatures, and it's kind of difficult. But that's pretty much it, guys. This guy's working properly. We're going to go ahead and put all the panels back on and give this one back to the restaurant and tell them they can use it. Forgot to mention, before I finished up, I put a new end on the plug so that way it has a proper ground now. So. Alright, so this was a service call on a Delfield prep table that wasn't working correctly. What I found was that the unit had a bad temperature controller. It's as simple as that. But I don't just stop at the temperature controller. I went through the operation of the entire unit to make sure everything was working properly, and then after I changed the temperature controller, I watched the unit cycle until it came within the temperature levels that I wanted it to be at. Okay? Nothing too crazy. It's very important though that you monitor these things and make sure that they actually come down to temperature, because it has a constant cut-in temperature controller, and low charge or TXV problems can drastically affect how the box works. So that's why you just got to watch and make sure it actually stabilizes out. That's pretty much it, guys. Right now you should see some other channels popping up. I suggest you give those other channels a shot. Consider subscribing to them, and I will see you guys on the next one, okay? Thanks a lot.